Hello everyone, I am Professor Ayiswarya. I am going to teach about module number 3, trusses. So here in this video, we will be seeing how to solve the truss problems. So the first one is some important notes you have to know before solving the truss numericals, or when the force F is applied at the center of the member of the truss. It must be divided into two equal parts, equal forces, that is F1 and F2, because you yourself should divide it into F by 2, F by 2. Okay, as like the following. See guys, there is a force F. It should be divided into F by 2, F by 2 for F1 and F2. Okay, when the force F is applied along the member, okay, but at the center it is divided as follows. For example, if it is applied at some distance a b, like that you are taking, means you need to take see guys, F into a. Okay, this is F into b divided by a plus b, a plus b, like this you have to take. Okay, instead of taking a plus b in the center, you need to divide it into two equal parts. And we will assume all the internal forces to be in the tension. Then after solving the problem, the positive forces are tension and the minus forces are compression, like that you need to categorize. So it is required to calculate the internal forces in each member of the truss and state if the members are in tension or a compression. So using the method of joints or method of section, you can solve. There are only two methods to solve the trusses. One is method of joints and another one is method of section. Okay, so all the internal forces should be considered, and the positive forces should be taken as tension and negative forces should be taken as a compression. Okay, so using that it should be resolved. And the next one is special cases are zero force member. What does mean by zero force member? Means when you look at the truss, you can determine them as see guys, when you have only two sides, okay, so one is equal to 0, the other side is 0, so directly you can say F is equal to 0. Four members each pair are on the same straight. See, for example, there are four members each line but in opposite direction, means you can tell F1 is equal to F2, F3 is equal to F4, like this. You can take this. These are all the special cases. By applying the equilibrium condition, you can solve this cases. So this is called a zero force members, or the application of forces. Like if it is in the varying direction, you can say, like directly you can allocate which direction it belongs to. Okay, and how to solve the truss members means, first you have to draw a free body diagram and calculate the external forces, and wherever the support reaction required, that also you need to calculate. You have to choose a single point or a node whose number of forces are unknown. First you need to see that it doesn't exceed, if for example if it doesn't exceed two unknown forces, then it is using equilibrium condition you can able to solve. For example, if it is only three forces, using Lam's condition you can solve. When it exceeds more than 2, you can use a equilibrium condition, that is summation of f of x equal to 0, summation of f of y equal to 0, and summation of m is equal to 0. Okay, and all the unknown forces you need to resolve, and you check that how many unknown forces are there. Maximum you try to resolve that with using the conditions, and you go to the next step, next node, and study the equilibrium using the evaluated forces. For example, previously if you have collected few using the conditions, if you have solved a few points and you have found the forces for that member, means using that you can go for the next step. Okay, and next if you are solving, you will be finding all the member forces. So this is how you need to solve the method of joints. And for the method of section, you have to draw an imaginary section. First you need to cut the trusses into two pieces, two section. Okay, and number of forces does not exceed 3, like that you need to cut. Okay, and you have to apply the equilibrium condition for one of the piece, means one section. The conditions are summation of f of x equal to 0, and the summation of f of y equal to 0, and the summation of m is equal to 0. Using three equilibrium condition, any one of the section you can resolve. After determining all the forces, the positive forces you should take it as a tensile one, and negative forces you can take it as a compressive one. This is how you need to solve the method of section and method of joints. When coming to method of joints, you have to see that whether you are having a zero force member. If zero force member is there, zero, straight away you can apply equal to the answer. Opposite forces, opposite forces are equal, like that you can apply straight away. Okay, so this is how you need to solve the method of joints and method of section. For method of joints, you no need to go for moment equation. In the summation of f of x equal to 0 and summation of f of y equal to 0 only, you can able to get the all unknown forces, all tensile forces. But when coming all tensile or compressive forces, but when coming to the method of section, it is not possible. So you have to solve summation of f of x equal to 0, summation of f of y equal to 0, and summation of m is equal to 0. If all using all three equilibrium condition only, you can able to solve all the unknown forces. Okay guys, so I conclude my the introductory part of the truss with this. Okay, and we shall see about how to solve those truss numericals in the next lecture video, and try to understand the difference between method of section and method of joints. And it's easier to find the node by node method joint, that is using equilibrium condition. You can easily solve the unknown forces. Okay, so thank you everyone. Meet you in the next video. Thank you all.